going to start with Scott from Chemistry about how he has used Learn in different, as a SharePoint for his students, and also he added more opportunities for students using quizzes and some self-assessments. He also used Learn as a community group to communicate with his graduate students. So we will have some questions and answers after Scott's session. We also have Linda with us, so we will also have some questions after Linda's session, and we'll have 10 minutes at the end to discuss both presentations. Thank you.
All right. So thank you very much for
one last thing that I forgot. I always forget this. If you have any questions, if you're joining us online on the live stream link, please ask Mary Power. Send the questions to Mary Power, and Scott and Linda will get to answer your question. Thank you.
Very good. Good to go? Okay, so I came to talk today about how I'm using Learn in and outside the classroom environment and the kinds of things that I'm doing to try to supplement that experience a little bit for students and, it turns out, some faculty as well. I guess the crux of what I'm going to tell you about is the gas phase clusters research group site that I've set up on Learn. So initially I set this up for my research lab for the students in my group so that they would have a central source for training and safety and the like. This has since expanded a little bit to include some other researchers and other graduate students in the Department of Chemistry. And I'm also now using this as sort of a centralized location, sort of a sandbox, I guess, for developing some of the courses that I'm working on. I guess in a nutshell, what I've done is taken the traditional view of Learn as a tool for coursework, and I've expanded that a little bit. So now we also have introduced some administrative tools and some research tools as well for my group. Okay, so these things are all sort of mixing together to some extent. So we have in the coursework traditional things like the chemistry courses that I'm teaching. I've also introduced a course that's purely for people that join my research team. So it's basically a computational chemistry course, as sort of a training tool for these guys to get up to speed when they first join my team so that the learning curve isn't so steep. And of course that could easily have been placed over here as well. So there's a mixture. As far as the administrative side of things goes, I'm using Learn sort of as a repository for reference material for folks that join my group. So it'll be things like safety information, standard operating procedures, startup packages for folks that join. On the research side of things, it's more along the lines of key references that anyone who joins my research team should be using to learn a little bit about what they're going to be doing. And we also have introduced some research highlights videos, which I guess evolved sort of from some of the stuff I was doing in the coursework, where I was developing some tutorial videos and master classes and the like. I guess I can walk you through a little bit of what we've done. You guys are all familiar, I think, with the Learn environment. So when you access my gas phase research group, under the admin section, we get things like the standard operating procedures, laser and lab safety, which are important for my research group. And of course, they're the regular layers of the onion as you go through. So some of these documents are, I would call, living documents. So the folks in my group have access to these, can update them, and then re-upload. So that way, if we have a new experiment that we've come up with, they can make the changes in the lab and then have some centralized location for other folks that are going to follow after them. Safety, of course, important, especially in a chemistry environment. So that's where I have things like safety data sheets, manuals for some of the instruments that we have. And this is all basically training for any undergraduate co-op students that come to my group, any honor students and new graduate students. Okay, probably the most interesting thing out of all of this would be the startup packages. Certainly the most useful. So as soon as someone joins my group, I give them access to the gas phase clusters research group, and they can access a startup package that basically in broad strokes outlines the responsibilities that they'll have in the group, the kinds of things that they have to do in the group, and provides a checklist for them so that they have, for their first couple days where they're out of sorts and confused, they have some reference point that they can go to say, here's what I should be doing now, and it helps them develop a little bit of comfort as well. So things that we would do would be, for example, sign off on an NSERC consent form to say, I'm allowed to be in this lab and I'm allowed to partake in the research that we're doing. Things like obtain your lab book, get keys for the lab, that sort of stuff, which I think most of us would take for granted, but maybe a new student who's out of their depth might train wreck a little bit. So something like that would be probably the most useful thing that we do for new people coming in. Of course, it's one of these continually developing sites. So the kinds of things that we're looking at doing right now in terms of the admin side of stuff is trying to develop some in-house training videos so that folks who join the research team as a graduate student or an undergraduate research assistant would have some resource outside of the other students in the lab to try to learn a little bit about what's going on. And this is sort of a carry-on from some of the stuff that we've already done that I'll talk about in a minute, where we have some tutorials, basics videos for people partaking in the courses that I teach. And I've also done some research highlights, which that's sort of a 2-minute summary of some of the research that we've done, which is nice for new students joining the group. They can watch these videos and get a better sense of what's going on. And of course, the students that have participated in the research also get a little web link that they can give their mom and say, hey, look what I did. All right. Okay, so in terms of research, the research side of things, here are some of the example videos that we've done. Depending on your web browser and your patches, you can either access that directly from Learn, or I've also uploaded all of these to a YouTube site so that we have sort of a backup in case the thing crashes. It never happens, but it's better to be safe than sorry. So let me see if I can show you, for example, what this would look like. So that's that's one of the teaching videos that I've pulled up, just so you get an idea of what you can access. The idea for these originally, like I say, was as a backup. Let's talk about potential energy. Anyway, I'm quite proud of those fades, so I'll let that go for a second. Okay, so anyway, they were originally conceived as sort of an extra resource for students to go and review a little bit. But they've turned into something a little bit more for me lately, because when you put things on YouTube, as you all know, everybody around the world can access, and YouTube gives you some nice analytics, which allows you to track the videos that seem to be watched the most, the times at which they are watched the most. So for example, I don't know if you guys can see this graph here. This is showing the watch time, and you'll see 3 spikes. And then a year later, another 3 spikes corresponding to test number 1, test number 2, and the final exam. Okay, so here's where people are really using these resources. If I scroll down a bit, you'll see that we will not become rich from putting these videos on YouTube, but I think that's not the point of doing this. You also get likes, dislikes, comments, which are another source of trying to temper your presentation a little bit to some extent. I think one of the things that I did very wrong when I first started was I spoke to my students as if they were graduate students or postdocs or professors, and it takes a little while to pull that back, rein that back a bit, and the best way to do that, I think, is through comments, particularly anonymous comments. Generally, they don't want to tell you to your face that they don't understand a word you're saying. Okay, so when we do things like these videos, we can also link that to the department website, to our online web page. So that also becomes a nice sort of contained package for everything that is me and my research team. And it provides other avenues for people to access some of the material that you've put online. Okay. And in terms of coursework, this is where it sort of all started, and then I sprang out from that. So, like I say, the coursework that I have on the gas phase research group, gas phase clusters research group, is more of a sandbox, but I also use it as a central repository for graduate students who are, say, about to take comprehensive exams or defend. In that case, I can give them a link to brush up on some of their basics, because there's nothing worse than defending a PhD and not being able to answer a first-year question. So things like this are quite useful. You can see that I have a course here with just a syllabus in it. So that is one that I just began developing last week. You can see I've made a lot of progress so far. But some of the other courses are a good bit more substantial. So that's the, I guess, training course for new people joining my group. Here are two that I've taught a few times here on campus. Chemistry 209, my spectroscopy and structure course, is by far the most developed one, because I've been teaching it the longest. And as a part of that, I have lots of resources available for students on here, beyond just the videos and the notes and things like that. All of my past assignments and midterms are available for the students, which is a bit more work because I need to make up new questions every year. But my feeling is that they benefit from all of these practice things. I've also started working on workbooks for the course. So basically what I've done is taken my course and broken it down into units, and then each unit has a workbook that the student works through on the way as we go through classes. So I'll say, okay, up to question 5 we've covered now, you should be able to work through that. If not, in your tutorial, bring it up with your tutorial leader and see where it goes from there.
Can you show us one of those?
One of the workbooks, yep. They're problem sets, but they also have solutions to them. Coursework. Uh-oh. Here we go. Workbooks. Oh, the electrons are slow on Waterloo today. You can do it another time?
Yeah, we can do it.
Oh, well, here we go. Here's a workbook example. Unit 5, which is going to be yeah, that's going to be some sort of Raman scattering type stuff. So list the fundamental constants of things that they'll need so they don't need to visit Google. Conversion table for any units type stuff. Obviously, I'm a scientist, so I need to include this sort of thing. Molecular dipoles for no particular reason, I guess. And then here are some questions with sort of gaps available for them to work through. They're on the honor system here, so they sort of work through them. And then after they've done their problem, there's a solution set available, so then they can see how I will have worked through. Of course, I tell them that not all questions necessarily have the same path to get to the correct answer. So if they have a different path, they can come talk to me about it. But that's sort of the gist of what we're doing.
Scott, do you do some of those in class as well? Or?
Yes, yeah. So I'll do examples very similar to in class, and then I'll say you should be able to now do this in your workbook or on past problem set, whatever. and then they can go have a go. And of course, I haven't ranked these problems, but I would say they go from like 1 star to 5 star. So if you're a real hero, you should be able to get the 5-star problem, but you know, most people I would expect should top out around 2 or 3 star. So that's sort of the idea. And it gives a little bit of dispersion and shows that there's more depth to the field than you'd see in, say, 2nd year spectroscopy. Okay, so here we go. Okay, I think I've already shown that. And the coursework. So here's the YouTube site again, where you can see the number of views in the top corner. So it actually surprised me. I wasn't expecting anyone other than the folks in my class to use this. And it turns out about 40 times more people use this than I teach, which is quite useful. And of course, in the analytics, you get a map of the globe and see where the hot spots are for people that are watching. So India seems to particularly like ramen spectroscopy. Okay, there you go. Okay, and I guess the final big resource that I would really use are the online quizzes that I've developed for my courses. So every time I offer a course, I try to add more and more to the test bank, and I have sort of random selections of questions for particular units, that sort of idea. So I have several hundred questions now with 38 quizzes I counted up that go from basic right up to advanced. So you can sort of gauge yourself as you go through these courses and decide how well you're doing and where you stand. The other thing that I've been working on lately is I've started using Top Hat. I've used it once. So this is an external client, which is sort of like iClickers. So I used iClickers right up until last fall, and then I thought maybe I'll try something new. Top Hat went quite well, actually. I think the students liked the fact that they didn't need to buy another iClicker remote because they seem to lose them a lot for whatever reason, but they don't tend to lose their iPhones. So this seems to work. On Top Hat, I have my lecture slides. I have in-class questions, which I use for feedback to try to gauge the temperature of the class to see, you know, how well they're doing, if they're following. You know, if everyone bombs a question, okay, maybe I'll go and talk about that a little bit more. That sort of idea. You also, with the Top Hat platform, get to do things like touch screen type questions. So rather than A, B, or C, I can show some diagrams and get them to point. So for example, here's one of these types of questions, which is the 3D atomic orbital. And if I can take another minute to allow my computer to catch up with us. If I go to Top Hat, there's that question again. And at the top, if I can scroll up, I get reports. So then I get to see who participated. If I dig a little deeper, here's how many got the question correct, got it incorrect. And we get things like heat maps, which then show us where people are touching on the screen more often than not. So that's a nice way to visualize how well you're doing, I guess, as a class. So they quite like seeing things like this as well. And back up again. Maybe. There we go. Okay, there's Top Hat. Okay, so I'm not going to tell you that everything I've done is great. So the nice thing about student comments is that they let you know when things aren't great. So some of the comments I've had is that I have too much content available on Learn, which is a danger, and there seems to be a sweet spot. So there's not enough, not enough, not enough, and then too much. Okay, so along with that comes hard to navigate. So this is where I started subdividing things into units and trying to give them some direction of how to find things. They tell me there are not enough examples in class, which is fine. So, you know, I try to add a few more here or there, but there are also tutorial sessions for the students. But as far as this goes, there are online tutorials, both video and paper form, or electronic form if you'd like, the workbooks, etc. For the administrative side of things, so these are students in my lab. They don't like the safety training or standard operating procedures, which I think will be a common thing that you get with new people coming into a lab. So you just sort of have to remind them that you do need to be safe when you're using lasers, for example. But I'm also trying to push that forward by developing some online content, particularly videos and maybe some of these top hat type things, I don't know, to see how that goes. In terms of the research side of things, the comments I get from my students are there's not enough, i.e. they want me to do a video of some of their research so that they can, right, and I tell them, why don't you do it yourself? No, we can't do that, so all right, I'll either have to teach them or do it myself, but I'm working on it. What we do right, so the things that the students seem to like, they really like having lots and lots of past problems to work through that are completely solved. So not just here's the answer, but here's the entire algorithm for how you solve something like this. They really like the videos that I put online. I think some people use those videos as a substitute for the lectures. I tell them not to, but some people do. Most people don't. So if you're afraid that you're going to put content online and folks are going to stop coming to your lectures, I think that won't be the determining factor for why they're not in your lectures. They also like the course notes and workbooks and all this sort of stuff that I add for free. And this interactive either clickers or top hat idea in the classroom seems to go over quite well. For the administrative side of things, this to-do list, the checklist for new students coming in seems to really go over well. They like that a lot, and they also like having this centralized, structured view of the research lab, because when you actually get into the research environment, at least mine, it's not particularly structured and centralized. So I think that adds a little bit of direction and reason for the kinds of things that we're doing. And in terms of the research side, I think the highlights videos and those key references are really the thing that folks are keying in on right now. So with that, I think that's all I'm going to say. I see I've gone 5 minutes over. I do that in my teaching lectures as well, so it's good to see I'm consistent.
So we can give you a couple of minutes for questions. If there are any questions we can ask Scott, otherwise we will keep all the questions to the end. Questions for Scott?
I certainly want to know, thank you. I'd like to know which pieces are widely available, which pieces are just for people who are currently registered in the course. What's access?
How I divide. So anything, so say I'm teaching Chemistry 450. Through the year, I do a little bit of tinkering in the research group, and then when the time comes, I usually email Mary and say, can you please set this up for me? And then anything new I port over directly that way. Senior students, so if they are in a special topics course and are truly interested, they come to talk to me, I just give them direct access to everything. Undergraduate students that are earlier in their degree, say my Chemistry 209 course, they would get basically the Chemistry 209 package that I've got there. Although some of them get very keen when they start getting into this stuff and decide they want to say do a little bit of volunteering or might want to do a work term, so then I just port those guys over into the gas phase research group as well. And it seems to work well in that sense. There is some duplication obviously when I do that for them, right? So if they're in 209, Chem 209, and then I give them the access to the clusters group, they get everything from 209 again, but everything else as well. And it seems that they're able to handle it. So.